agentic AI services layer, which is now being introduced in the architecture, which is, let's call this as the AI agent layer, like this API gateway, and then this AI service layer, or you call it this one. This is the new brain of the system. And how we here we deploy AI agents chains that perform intelligent multi-step workflows, right? So as I mentioned, each agent is essentially a service or a set of function. It could use AI models, it could use LLMs, it could use standard robotic process automation Python libraries, right, to perform a task. So crucially, agents can call other agents or tools in sequence, a concept known as chaining. So for example, an analysis agent might invoke a summary agent after it fetches data, forming a chain of reasoning. An agent may also communicate amongst themselves to divide tasks, right? A very important framework to implement this is called LangChain, right? And that is specifically very important. Let's say it makes it easier to orchestrate LLM calls and tool usage. You look at LangChain and how it makes it easier to implement the chaining mechanism and have LLMs talk to each other. LLMs talk to your, actual service. So it's a middleware, right? And these agents would operate asynchronously, autonomously. And a very important point I want to make here is asynchronous orchestration, right? So traditional request response calls are brittle for AI workflow. So instead, the architecture uses an event-driven approach because, and I touched up on this as well, that all these agents need to talk to each other. And let's say you have a multi-agent system, right? So agents publish and listen for events, enabling loosely coupled communication. So for example, when new data is available, an event like document uploaded can trigger a chain of AI processing steps. So agents consuming that event can work in parallel or in sequence as needed. And this decoupling is key to scalability. So it prevents tight linkages between services. So, and how can you actually enable this? So in practice, technologies like message queues or streaming platforms like Kafka, RabbitMQ offer underpin this and make this possible, right? The result, agents don't stall waiting for each other in a web or HTTP calls. Imagine there's so many HTTP calls, but rather you focus on an event-driven architecture, right, where they're actually talking to each other. And go back to the example of when I talk about a development squad, where a front end talks to a back end and a back end talks to, let's say, a product manager, front end talks to UI, UX, and all of these guys are talking to each other. So they respond to events, work asynchronously, and the overall workflow becomes resilient through an asynchronous orchestration and event-driven workflow, right? Now, I spoke about multiple databases as well. So, operational databases, and then the vector embeddings, right? It's important to understand that for each agent and to have its own knowledge base, or let's say for each agent to contain its own database, from my opinion, a NoSQL database would be better off because go schemaless, right? Or, and specifically if you talk about, let's say, vector database, we have Pinecone and a very disruptive tool which is out there nowadays is Supabase, which is Postgres plus PG Vector, and you should definitely look at it. I'll talk about these tools in the coming slides. I want to talk about the API gateway and the integration layer again, because you saw that, how these operate, right? But remember that the API gateway should sit at the front, and whenever you're getting a client request, it routes it to traditional endpoints, AI workflows, right? So, I'll give an example. So for example, a client might call post generate. So it's a post request to generate a report, right? And it's a report which is essentially fetching data from your database and creating a PDF and then responding to the client. So the gateway would direct it to an AI orchestration service rather than a single micro, like the other traditional backend. And the gateway can also handle cross-cutting concerns, authentication, rate limiting, and so on and so forth. And in a hybrid workflow, a single user request might invoke both standard and the AI agent. So let's say you've invoked a generate report, it goes to a specific AI agent through this API gateway. It fetches the relevant data from your database, let's say the traditional backend database, or its own database where you're also pushing the data responsible or required by that specific agent. Now that's where it gets interesting, because a lot of times, if you're relying on the backend database to serve the AI agents, it would get crazy. There were so many requests. And that's why it's important to consider having separate databases. And let's say the report requires a specific subset from your traditional backend OLTP database, push it through a job there as well, right? And what it does is the agent talks to its own database, fulfills response for that specific user, and pushes it directly to the client. And that's where you need to think that you're actually segregating your or routing or delegating your workflows, but also reducing the load on the database, right? Because one traditional backend OLTP database could not do so much, right? All you need to do is like maybe have a logging and monitoring mechanism in that backend database to know, okay, which agent has performed operation A, operation B, and a separate database which also contains like the logs of all agents, because you need to sort of have, logging mechanism in place, which I'll sort of speak about earlier. So 7 to 10. Okay, so we have 36. Okay, 45. I want to talk about the real world examples and use cases, because a lot of times people might be confused right now. Like, I'm talking about AI agents, but give me an example, right? It's important to relate it to the business, right? The first one is PDF data extraction automation with agentic AI, right? I've been speaking about it because it makes it easier to relate to it, right? So scenario is that a business receives hundreds of invoices or forms in PDF format daily and wants to extract structured data like totals, dates, line items into the database. The traditional approach is either manual data entry or writing specific parsers for each document layout. Very labor intensive and brittle. And a monolithic app might have a hard-coded PDF parser module. A microservices approach might provide a parsing service, but it will still use static rules or OCR templates, right? Let's talk about the agentic AI approach. An AI document agent handles this workflow. When a PDF is uploaded, triggering an event, the event breaks the PDF. The agent breaks the PDF into text. So let's say using an OCR tool, or a library, Tesseract, Paddle, etc., and then and even Mistral's OCR is one of the best nowadays, if you look at it, and then uses an LLM to interpret and extract the required fields. For example, in my Prompt GPT-4, here is a document text, extract fields XYZ. LLM's flexibility allows it to work on any layout by understanding context, not just fixed positions. So the agent then calls the backend invoice service API to save the extracted data, or let's say just the one backend, your traditional backend, as I was mentioning earlier as well, to save the extracted data just, but the agent itself has its own database where it's doing logging and etc. and all that stuff to keep a log, right? But the final output goes into your backend database. It might also chain, verification step. If high uncertainty, route to human for review, human in the loop concept, all extracted info is also vector index for future semantic search. So for example, you could go like in the future, find invoices from ACME Corp or find invoices from XYZ Corporation. Result. What is the result here? So what took manual effort or complex coding is now largely automated by an AI agent that can adapt to varying document styles. The backend architecture supports this by providing the agent access by APIs to store results and by logging the agent's actions for review. Let's talk about intelligent document summarization with agentic AI, right? So let's say, a company wants to generate concise summaries of lengthy reports or knowledge-based articles for employees or customers. And a lot of times, in organizations, there are sales teams, there are proposals coming in, or let's say you have a PDF and, you want to summarize it. There are all tools out there, but generally you want to build this within your own software. So the old way is possibly simple script calling an NLP service to summarize text, which might choke on very long documents or lack context integration. Imagine doing this in your own backend service, right? Just one monolith. Or employees read and summarize manually. The new agentic way workflow is a summarizer agent orchestrates this task. So when a user requests a summary, the agent might perform these steps: retrieve relevant content. If the document is huge or spread across multiple files, the agent queries a vector DB or search index to pull the pertinent section. So using embeddings to find what's about the topics, right? Then you chunk and summarize iteratively. The agent breaks the text into manageable chunks that fit the LLM context window, summarizes each, and then asks the LLM to compose an overall summary from those piecewise results. Now, this chain of thought approach prevents loss of text that a one-shot summary could suffer from. The agent might also call like a company policy service to fetch any guidelines. For example, always include a disclaimer, showing it can integrate internal data with AI generation. And finally, it returns summary to the user. And all this is done through the architecture, the hybrid architecture. The request goes through the API gateway to the specific summarizer agent, and the agent uses the vector store to retrieve text, because let's say these documents are vectorized and stored in a vector database, and possibly calls other agents for context as well. That's where agent-to-agent communication could come into place as well. LLM is used in multiple steps, and the workflow is dynamic. So if the document were updated, the next summary would automatically reflect new info because the agent rereads from the source rather than using scale logic. What is the outcome here? Rapid on-demand summaries with understanding of context. So imagine that you're saying, summarize the 50-page quarterly report in one spread for an executive. And ta-da, you get a response right away. Dynamic customer support with agentic AI, something, we've been talking about a lot, specifically when, robots or like chatbots came in, Dialogflow came in, and a lot of other chatbot frameworks came in to automate customer service. Now, how could agentic AI help you in dynamic customer support? So the challenge is that traditional support automations like IVRs or chatbots follow fixed decision trees. A lot of times, yes, they are, like if you talk about Rasa or if you talk about Lewis, Dialogflow, there is intent detection and there's some NLP involved, but a lot of time they would fail for nuanced queries, and and then they would integrate different multiple backend systems. Like let's say for user authentication, they would query the database, and if they want to log a ticket, the bot would actually log a ticket in the database. So but the problem is, in real time, a lot of the bots which were built by companies are rule based, and there's not a lot of dynamic play into those, and actually sort of learning on its own and adapting on its own, right? Where reinforcement learning would also come in. Deploy, let's say you at your organization would build like an agent called support agent. That's an AI agent again that can sense, analyze, act across the support workflow. Sense, so the agent takes in a customer query, chat or email. It then gathers context, retrieves the customer's history from the CRM system via API, pulls relevant product info from a database, and perhaps checks recent similar issues, searching a knowledge base. So you have also a knowledge base by vector embeddings, because you are actually maintaining a knowledge base of all customers and their tickets in a vector database. Analyze, it uses an LLM to analyze the query sentiment and complexity. So is the user frustrated? What are they asking? And it decides on a course of action. Can it answer using the knowledge base, or is this a complex issue needing human intervention? Plan and act. Suppose it can handle automatically, the agent might call, knowledge base to formulate an answer, then interact with the ticketing systems API to log the response, and even trigger a refund process through an order service or your backend service if necessary. It writes a reply and either sends it directly to the user or queues it for a support rep's approval. Human in the loop. Learn. Finally, records the outcome. Was the solution expected? If the solution gets escalated to the agent to human, the agent can watch and learn from the human's resolution for next time. Now, that's where you're also bringing reinforcement learning into place. But the beauty of this is that a lot of this was done by humans. Now it's done with this support agent, which is rolled out in your hybrid architecture, which was presented earlier, right? Now, the API gateway knows that it has to route this process to the support agent. Throughout this, the observability layer, which is very important, I've been speaking about it, logs each step. The complex workflow touches multiple systems and require on-the-fly decision-making, exactly where a traditional hard-coded workflow would struggle. So in contrast, the agent can handle asynchronous waits, waiting for a database response, make independent decisions, and coordinate across systems, right? For example, an enterprise support agent might retrieve customer history, analyze sentiment, generate a personalized resolution, and trigger actions across various apps. Result, faster response time, 24/7 service, and the ability to handle unexpected queries by reasoning, not just by matching FAQs. A lot of times, whoever has worked on, bot frameworks, it's a lot of FAQs, and that's where they would fail. Tools. Some of the tools mentioned here, not all of them, to be honest, right? But LLM and agent orchestration frameworks, I've spoken about this. LangChain, popular framework for developing these agent workflows, provides abstraction to chain LLM calls, integrate tools like web browsing, calculate, and manage context between steps. So using LangChain can actually speed up development of agentic services by handling a lot of the boilerplate of prompt management and tool invocation. And other alternatives in this space include, Llama Index, prompt engineering SDKs, but LangChain is a go-to for many because, it natively supports connecting to vector databases, LLMs, different LLMs, APIs, etc. Foundational API, model APIs, this, OpenAI, GPT-4, 3.5. You could use, Azure hosted OpenAI, and that's where I would come to when we talk about security, Anthropic Claudes, and vector database for agent memories, Pinecone, etc. You should look at Supabase. It's a hybrid data platform. Towards combining traditional and vector storage. So you should read about on Postgres. It's a combination of Postgres and PG Vector, right? So and it's a great alternative to Firebase. So meaning that you can store embeddings alongside normal relation data. That is the beauty of Supabase, right? So an API gateways like Kong, APG, AWS API, observability stack, Prometheus, Grafana, where all the observability takes place, and miscellaneous AI services. You could even there's Pinecone, there's Milvus. Milvus is open source if you want to deploy it, let's say on premise, right? And because I have less time, so I'm gonna just data security and governance implications, and that's where a lot of business leaders, owners, they will ask, how do we control this? Where is the security? How do we? So rigorous access control, autonomous agents might need access to many systems, database to do their job, which raises the stake for security. Apply the principle of least privilege to your AI agent. So each AI agent gets only the API permission it truly requires and nothing more. So for example, if an agent only needs read access to customer data, its credentials shouldn't allow write-offs. Rotate these credentials regularly and monitor their use. If you're using an API gateway, you can ensure strict auth on AI endpoints as well. You don't want an external user directly hitting an internal agent by bypassing controls. And auditing and traceability, everything an agent does should be logged in immutable audit logs. So in a traditional system, you might log transactions. Here you log AI actions and decisions. So if an agent sent an email to a client or made a database change, you need to record what was the input, what decision was made, and what basis. So these logs are crucial for debugging incidents like why did the agent approve a $10,000 refund and for compliance. So they provide traceability. You can explain later what sequence of events and reasoning led to an outcome. Ensure your logging does not expose sensitive information. Preventing data leaks. AI agents, especially those using external APIs like OpenAI, need careful data governance. So you must ensure no sensitive data is sent to external services. Strategies, anonymize or mask customer data before an LLM sees it. You can do it. Replace real names with placeholders or use an on-premise model for highly sensitive content. Like you can deploy, let's say, DeepSeek, Llama on-premise. Also consider encryption for any data at rest in with vector database. You can do that. Vector can sometimes be partially decoded to the original text, so treat them with care. And check your vendor agreements to ensure that they don't train on your data. And this is where I was talking about Azure OpenAI. So if you host OpenAI within Azure, they will not use your data to retrain. And also if you use OpenAI Premium, they will not do it. So Claude, OpenAI, there's a lot of questions and concerns on this. But let's say you want to use Claude in a private instance, go use AWS Bedrock, right? So AWS has a partnership with Claude, and Azure has it with OpenAI, right? So you can host them within your VNet. What is a VNet? It's a virtual network where you can host your own LLMs, or in outside in the US, there are also private clouds available by Azure, where let's say, different companies have their own private cloud where hosted, let's say, on a dedicated servers provided by Microsoft. And guardrails in practice like extend the traditional security checks to AI-specific guardrails. This can include setting bounds on autonomy. Some agents might not be allowed to execute certain actions without human sign-off, validating the outputs and robust input validation from prompts to prevent prompt injection attacks, where a user tricks the agent with a malicious input. As noted earlier, guardrails ensure agents stay focused on allowed tasks and provide diagnostic info when something fails. So this might involve building a library of common fail-safes. So if the agent's response confidence is below 50%, automatically route it to a human. Don't respond to the client or the user. Or if it's about to perform a destructive action, delete user account, require a secondary confirmation path. So the agent cannot do this, right? And a lot of times the system prompt, let's say you're building an NLP SQL system, you can define this in a system prompt that you're not supposed to delete. But let's say if it does it, it does not commit to the database before it is approved by a human, right? And that's where I think it could be very interesting is the GDPR compliance. I'm not sure if you know about it, but GDPR compliance says that if a user leaves your platform and you're supposed to delete the user's data and also delete the data you've used in LLM workflows and ML models. You cannot do it anymore. And that's where you can actually automate this through an AI agent with a human in the loop action that, okay, because this user is left, and as per GDPR compliance, I'm going to delete this user. Should I? And you look at what it's deleting and you tell. So imagine replacing that with an AI agent. So data observability, I've spoken about it, but it's important, please, to follow or incorporate tracing into your agent workflows to follow user requests as it traverses backend APIs and agent steps. So for instance, if a workflow goes API gateway, auto service, agent, external API, you want a trace ID tying all logs together. How did this start and how did the agent end? Metrics, collect metrics from HTTP request, from your backend LLM response times, token usage, how many tokens were used by the agent. Tools like Prometheus, Grafana are great, but let me tell you, if you've used MLflow, start using MLflow LLM Ops. They've actually launched LLM monitoring within MLflow, and it's mind-blowing. So MLflow LLM monitoring is mind-blowing, and it's great. You should definitely look at it. Logging, so log everything from agent decisions. AI agents should log their actions. Proper observability. Let the team answer what did the AI agent do and why. Quickly pinpoint if an error was in the AI logic versus backend. And ethical and policy compliance, and real-time monitoring and quill switches.